All right, how are we doing today, guys? So how does it feel? Does today feel like a Tuesday to you all, or a Wednesday, or feels like a Monday to me because I didn't teach yesterday, so it's just weird. But then Friday's going to come up and it's going to feel strange, like I guess a short week. I guess that's the benefit of having that extra holiday. That's why I would like to have a holiday every week, but nobody listens to what I say. Some announcements. First and foremost, for those of you who had requested a print copy of the book, they're in the bookstore now. You may go pick them up. There are two students who actually asked about that, so you may reach out to them, talk to them about that. So that's good news. Also, remember we talked about extra credit activities in this class, and I said that there were basically two opportunities. The first one is coming up this coming Friday, and it's Meet the Firms. It is primarily designated for accounting majors, which is a majority of the people in this class. But if you're not an accounting major, fear not, there is another opportunity. You can also reach out and see what the firms are that are going to be visiting. There may be some opportunities for, even if you're not an accounting major, some opportunities for you to be able to talk to firms that are visiting. But when you do attend Meet the Firms on Friday, please make sure that you swipe your ID at the front because I will be getting a list of everybody who attended. If your name's not on the list, then just no extra credit whatsoever. Now, if their name's not on the list, I'll post it. I won't post your name as extra credit, but then you can reach out to me and say, Dr. Barnes, I attended, and I'll chide you mildly, saying, why didn't you swipe your ID? And you'll say, I did. They just messed it up. They called me somebody else. And it's always a story like that. But no, just make sure that you sign in and everything will be fine. If you cannot make it on Friday or it's not appropriate to you, keep in mind the Career and Internship Expo is coming up in a few weeks later. I guess technically about 3 weeks from tomorrow. It's on Thursday, September 25th. That's going to take place over in the Student Union. Those are the opportunities for extra credit, 5 free points. Just a good opportunity just to, as we said, develop those professional networks and find out career opportunities for the future. All right, how are we feeling? Sorry, go ahead. So Meet the Firms will be, I think,
10 to 2.
10 to 2, and I think the Career Expo is roughly the same time. Yeah. I'll have more details about Career Expo when it comes up, but Meet the Firms, yeah, 10 to 2. Apparently people are on top of this more than I am. Yeah. So appreciate the insight. Yeah. All right. So I'm glad everybody's feeling pretty well rested today. Today is my least favorite chapter of the entire course. Yes, well, Dr. Barnes, if you don't enjoy it, why do you teach it? I do think it's a critical concept to understand, to be able to impart this information, to be able to interpret this. That being said, it is a very, very challenging series of topics. Today's not going to seem that bad. Keep in mind that the way this is going to be set up is I'm going to be introducing these concepts to you today. We're going to be applying them over the next few weeks. So we'll have some application next week when we talk about relational databases. We'll have a lot of application when we get to the process areas. So the stuff that you learned last week and this week, it doesn't seem really applicable now. It will seem very applicable when we start talking about revenue process, purchasing process, inventory process. You will need to know this stuff really well. And you're asking, do I need to know it well for the exam? Absolutely. Please make sure you take diligent notes as I'm going through here. I will tell you basically the format, the framework that you'll need to understand. I'm going to be introducing you to concepts at a little bit more rigorous detail than I will expect you to know for the exam, but that's just kind of give you context for all of the information you will need to know. So if I say this is an important slide, you should probably star that and say, know this. This is important. Write that down. So let's go ahead and talk about data modeling. Specifically, this is a chapter on UML diagrams. Our guests who are presenting at the beginning, they bolted out of here when I said we're doing UML diagrams today. They both actually had some exposure to this. It's not a fun topic, but it can get worse. So when we see what we're going to look at, I'm going to kind of give you an example of something that I call UML nightmare. This happened during the pandemic a few years ago. I took a class on REA UML, which you'll understand what those words mean in just a second, or those letters mean in a second. This is what we were expected to do for homework, by the way, this particular diagram right here. All right. So you're asking to yourself, is this what we're going to be expected to know for the exam? The answer is no. All right. I'm not going to give that to you. This is so far beyond what I would expect. It is literally a nightmare. This was given that these were instructors who had just been used to introduce these concepts. They said, "You want us to replicate that?" Really? It was kind of a tragic thing. But the reason I bring this up, first of all, this is going to be two reasons. First of all, this is how complex it can get if you don't have good guidelines, which we're going to talk about, very specific, clear-cut guidelines. And more importantly, it can be a lot worse than what we're going to interpret. What we're going to get into, especially when we get into the process areas, will be what seems somewhat convoluted. That is the true meaning of convolution when we talked about what was on the diagram. Okay, what we're going to be doing today, very straightforward. So remember, we have our business models, business process models that run into. So we're going to talk about business rules and how they're characterized, but the business rules are characterized within two model contexts. One of those we've already talked about. We talked about last week activity models. That was our BPMN diagrams. And now our BPMN diagrams, I said that they were complex, but when we presented them, they were pretty straightforward. And that's kind of my goal for this course, to take complex concepts and to narrow them down into the information that is very, very straightforward and kind of walking along specific guidelines. So BPMN diagrams, while they represent a lot of complex detail and a lot of complex exchanges of information, the way that we're going to interpret them are not going to be too difficult. Again, keep in mind that we have not contextually defined this information yet. When we get to the business process chapters, it will become a lot more clear. Today, we're going to talk about structure models, and structure models, specifically UML diagrams. The way that I characterized them last week, as I said, activity diagrams are the way that a human being would think about a process. Structure diagrams are the way that a computer sees a process. And there's going to be a pretty big delineation when we start talking about that. Okay, so structure models, they're going to describe the entities or things in the domain of interest. Now, I'd like you to make sure you make note of that term entity, because that term entity is really, really important. We need to be able to define our entities for this process to even work. If you don't know what an entity is, you're going to be so far behind when you hit the exam that it's going to be a challenge for you to be able to do this process correctly. So there's a reason why we say entities are things in the domain of interest. I always struggle with that term things, but I don't have a better definition until we actually get to what we mean by things in the domain of interest. Then we're also going to describe the relationship among those things, with those items, what it is that we're trying to identify. So we're going to have very similar kind of framework to our BPMN diagrams, though it's going to represent different concepts. We also need to specify how many instances of one entity can be related to another. This is probably the most challenging aspect of this, is we need to understand these relationships, but also be able to depict these relationships between these entities or these things in the domain of interest. And then identify the attributes and characteristics of the entities and relationships. Make a note of this. This will not be explicit, but will be implicit in our diagrams. We're going to stick with fairly basic diagrams, but these attributes and characteristics are going to be important to understand, because our next point is to roll forward to understand how we use a diagram like this to prepare a database. In order to be able to develop a database, we have to understand what are the attributes or the characteristics that are implicit within these diagrams themselves. So as I referred to, we're going to be talking about Unified Modeling Language, or UML. Now, UML employs class diagrams, that term class being really, really important, to describe logical structure of a database system. So when we start talking about relational databases next week, I'm going to refer a lot back to what we talked about this week. In fact, I'm going to have some spoilers. I'm going to be talking about some concepts that are not going to make sense right now. They will make a lot of sense when we get to relational databases. Has anybody taken a database class in here? So relational databases should be somewhat familiar to you already. I won't talk about them in the Access context, but I will talk about it from an Excel context, since that's something that we're all familiar with. That being said, I would not create a database in Excel. That's just a bad idea. It's setting yourself up for failure, but it's an easy visual example. So remember, I mentioned UML is obtained by the Object Management Group. So again, all of your hate mail goes to them, not me. Okay, so yeah, they're the ones who developed this. I will say this is actually a pretty clean solution to the problem. It's just the problem itself is very, very daunting. So UML elements are going to have a few common elements that we're going to be very focused on. So the very first one are going to be called classes. These are items about which the organization wants to collect and store information. Now, when we looked at the diagram that I put on the UML nightmare diagram, it was representing classes through this depiction right here. So this is a basic class symbol with name, attributes, and operations compartments. So we actually have one rectangle that's got three different characteristic fields. We've got class name, attributes, and operations. That is the complex end. That is the far end, and this is the example of this. This is going to be class symbol with name only. That's what we're going to be using for this course, okay? We're going to be using the class symbol used in the textbook. So why do I actually explain? Two reasons. First of all, because you do need to know what the implicit operations are within a certain class, okay? You need to understand those. Secondly, we're going to look at some examples of the complex version. I don't want you to freak out and say, oh my gosh, I'll never remember this. You will not be asked to replicate these classes, but I do expect you to understand what is implicit within the class. So now this is probably one of the more important things to talk about this next section. All right. Classes can represent one of four areas. One of four areas. They can represent resources, events, or agents. Now, I want you to note these resources, events, and agents. These are collectively called entities. Does everybody remember a few slides ago when I said entities was really important? You had to make a note of that. These are those representative entities. So when I say, what are my entities? You're gonna hear me say that a lot within this context, because we're going to replicate a lot of UML diagrams or create a lot of UML diagrams. And I'm going to say, first things first, what are my entities? You should be able to say they're the resources, events, and agents. Now, when I say what are my entities, I don't want you to say resources, events, and agents. That's basically what they're defined as. We will actually be able to provide context for what each resource, event, and agent are, but we'll get to that point here in just a second. So when I say entities, you should think resource, events, and agents. These are pretty straightforward, okay? Resources are basically assets used by the entity itself. So trucks, machines, buildings, cash, investments are all things that we've seen as assets on a balance sheet. Events are transactions that take place within the organization. So sales, purchases, cash disbursements, cash receipts. Agents are the individuals who conduct those transactions, both external and internal to the organization. So customers and employees. Now, that seems like a pretty limited list. And trust me when I say it can go well beyond that. But for right now, those are the only items that we really need to talk about, simply because we're going to keep our list of entities pretty straightforward and simplistic. Can we make it more complex? Can we talk about a lot more users or a lot more agents, a lot more events? Answer is yes. Certainly, there's going to be a lot more complexity to be added, but it's going to be complex enough as it is. So this is going to be our basics framework. Now, you will notice all entities are classes, but not all classes are entities, because I specifically defined resources, events, and agents as entities. There's this last item called a conceptual structure. This is one of the more confusing parts of UML diagrams, and a conceptual structure is basically something that a manager would like information about that is not an entity. So something a manager wants information about that's not an entity. The way I would define these are like accounts, product categories, budgets. These are kind of all items that are generated by the organization, but don't really fall within the framework of the other three items. So when we say what is a class, classes could actually be one of four items. They can be one of our three entities, or within the UML diagram, we can actually have a fourth item, conceptual structures. Now, you don't need to anchor too much on conceptual structures. I'm not going to ask you too much about them, but you will need to be able to understand how they fit within the larger framework. And there will be some examples that we'll have to include those. Trust me when I say it will become a lot more apparent once we look at UML diagrams, how these fit in, but it's not necessarily clean. They don't fit within our existing framework very cleanly. And we'll see why that's the case here shortly. So classes, that's our first piece of information we need to know. Now, remember, we talked about classes are entities or things of within the domain of interest. That was our previous definition. Then we're talking about the relationships between those classes. These are called associations, okay? These depict the relationships between classes, like a person owns an automobile. And ownership would be the example of the association there. All right. And we can actually interpret the association in both directions. Okay. A person owns an automobile is owned by a person. That's how we would depict the association there. It's pretty intuitive, but it's a really important depiction to make. Next, we have something that's not intuitive, and this is something called a multiplicity or multiplicities. These represent the minimum and maximum number of times instances in one class can be associated with instances in another class. This is one of the unique tweaks on UML diagrams, and trust me when I say it is a major pain, all right? It's really important, but it's a major pain to interpret. So the very first thing I want to tell you about is multiplicities are not intuitive. When we talk about a multiplicity, we start with one class, and we go to the far multiplicity, and then interpret it in relationship to the other class. So example, a person can own 0 automobiles. Okay, I'm sure many people in this room, they probably don't own their own automobile. Either they're borrowing it or they just don't have one yet. Okay, some people may, but most people, when I was in college, I didn't own a car, so that was an example of me. Or a person may own multiple automobiles. So 0 to star. Star means multiple, by the way, and it actually tells you what the relationships look like right here. So 0 to star is saying a person can own 0 automobiles, a minimum of 0, or a maximum of many automobiles. All right. Does that make intuitive sense to everybody? Once we actually define it, it's intuitively sensible, but the actual relationship itself is difficult. An automobile can be owned by one person and only one person. This is the 1-to-1 example. So a minimum of one, a maximum of one. All right. Now you can take umbrage to that, say, well, an automobile could be owned by nobody. It could be sitting on the side of the road. Or you can may say, maybe everybody in the family owns an automobile. Again, you can make arguments on some of these, but this is what the multiplicity is telling us. An automobile is owned by one person and only one person. That's how this is represented. Okay. So that's how multiplicities work. Now, this is a very simple example. It's pretty straightforward. We're going to be looking at a lot of different examples. You're going to have a lot of homework examples that you're going to have to look at the diagram and interpret multiplicities. You're going to be very, very sick by the end of this homework, and we're not even done after this homework. Okay. So this is one of those ones that's a chore and it's a challenge at the same time. So we'll get to that in just a second. We'll get to a little bit more detail what that represents. The final one we're going to talk about is attributes. Okay, or I shouldn't say final, but these are a little bit more. This is not the final one, but this is going to be something that's a characteristic of a UML diagram that's not explicitly stated. All right. So these are data elements to describe characteristics of the instance of the class. Okay. So our class are represented by records, whereas attributes are represented by columns. Now, the way to think about this is the way that we presented this in our Excel example last Friday. So we're doing our Excel example, and I presented all the records that I had for each of the individuals that were in my class. Remember, I said I used constructor names, and then I said their middle names I made up. These are each individual records, and they're represented by the rows within the spreadsheet. And then each of the columns represent attributes of the individuals, or attributes of the records. So each record has a banner ID, each record has a last name, each record has a first name, so on and so forth. All right. So one thing to note, I probably harped on this already, but I want to make sure it's very explicitly clear. We will not be depicting attributes in our UML diagrams, but we do need to know what the attributes are in order to be able to put them within the database. So to be able to transfer a UML diagram to a database depiction, we have to understand the attributes. So say, for example, you are the class that's in a UML diagram. What are attributes that you possess? Well, everybody in this room has a banner ID. Everybody has a last name, has a first name. Most of you probably have a middle name. You have an email address. Those are examples of attributes that you would prepare and put in the database. In fact, I know that those are in a database because I've got everybody in this room on a spreadsheet right now with that information. I don't think I put down your middle name. I think I just transferred over, but it does present your middle name in banner or whenever I look at that information up. So the full specification of attributes, which is going to be our data dictionary that defines all that, would include data type, default values and constraints in the value, which are minimums, maxims, and other descriptive information. So if we were going to go into depth, we would have a big data dictionary that would describe every single one of these attributes in detail, and it would tell me what is the data type. So is it character? Character, is it numeric? What is it going to be? Are the default values, is it going to be blank, or do we put something information in there? Constraints and the values, what should the value be, the highest and the lowest? All of those would be depicted within our data dictionary. Now, the biggest reason I put this in here is just to define what a data dictionary does with respect to attributes. You're not going to be doing a lot of that within this course. Trust me when I say the UML diagrams by themselves are enough. All right. Leaping forward to something that's important to note for chapter 6 is going to be our keys, okay? Now, this is how this information is depicted within a database. The first thing to note is going to be a primary key. A primary key is an attribute or a combination of attributes that uniquely identifies each record. Now, let's go ahead and think about what is our unique identifier. So I've got my students within this classroom. What is my unique identifier for these students right here? Or better question would be, what is the unique identifier that each of you have within this class? Is it your name, your full name? Is it possible that we could have two people with the same full name? Yeah, I've had it happen before, so it's a possibility. So what is it going to be? Banner ID. Everybody's got a unique individual banner ID that's been assigned to them. It's like a 9-digit ID. I think we're in the tens of thousands right now for Truman State because we've got 7 of the 9 digits taken up. Everybody starts with 00 right now in their banner ID. Once we get to the millions, that's going to be well past my time at Truman State. Okay, but I wish them the best in getting millions of students. So yeah, the banner ID is a unique identifier. Now, there's a few things to note, and we're going to revisit these next week, but I do want to make some quick notes about these. With respect to primary key, it cannot be null, okay? It cannot be a null value. This is part of something called the entity integrity rule. You can write that down or not. Trust me when I say we'll revisit this one. And it should be controlled so it will not change over time. So that's going to be an example of something that if we think that something may be a good unique identifier, we have to say, is that something that can change over time? Many people in this room have a social security number. That's an example of a number that would not change over time. And so that's something that we would hold constant, and hopefully that would be consistent and won't have to worry about changing over time. Whereas telephone number, you can have many telephone numbers over time and have most of mine I've forgotten. So I've had the same number now for almost 20 years. So yeah, that would be one that has been consistent, but not necessarily held consistent. Also, we've got something called a foreign key, which this will make more sense once we get to the relational database. A foreign key is an attribute or a combination of attributes that allows tables to be linked together, okay? So we're going to look at this within the UML diagram context shortly, but an example would be is that if we had a table that had personal attributes, so remember, these are all personal attributes of people in this room, then we had another table to list the types of vehicles, okay? All of the vehicles and the cost, the type of vehicle, I don't know, the number of doors, the color of the vehicle, the model, the make, whatever, all these attributes. Then we could actually have a sales transaction database that would have both of these listed there, what the car was and what the individual who bought the car was. And those are that represent foreign keys that are used to match the person who bought the car, bought the automobile in a particular transaction. The idea being is that we can't necessarily delineate what the relationship is unless we can match one primary key to another primary key. Now, that's not very easy to do, but we can actually work through that through the use of these database tables that we're going to be working on over the next couple of weeks. So our goal of foreign key is to be able to actually link tables together. And trust me when I say this is a pretty profound endeavor. If we go back 40 years ago, this was something that was not possible within computerized systems. It didn't occur until fairly recently, within the life of humanity, I guess I should say, fairly recently. And it's a big, profound change that allows computers to be, or computer databases to be far more effective and efficient. All right, a few things to note about primary keys and foreign keys. We're going to reflect on these next week. Should you use social security number as a primary key? The answer is no, because not everybody has a social security number. Remember, our one thing that we said is that primary key cannot be null. What if you're a student who's coming into the United States and is going to be here for a while and is going to go back home? You probably don't have a social security number, so that would not be a good unique identifier. Should you use people's names as primary keys? No, for the reasons we talked about, because people have the same names. I've had one example of two students with the same name. They were both in the same class, not same course, but they were same grade level. I don't think they were ever in a class together, which was funny, but they were right around the same time. The interesting thing was one was a short brunette female, another one was a former military guy. And so there was a big distinction between them, okay, but they had the exact same name, same first name and last name, and I thought that was just a really, really odd scenario to have, because you'd think that wouldn't happen. But anyway, okay. And then should you use phone numbers as primary keys? No, phone numbers change over time. Should you use primary keys using sequential numbers? And this is an interesting one. The answer is yes, and we're going to talk about controls in a lot more depth over the course of the semester, but this would be an example of control, because if we use sequential assignment, this can actually identify gaps in sequence. So say we're reviewing all of the students who enrolled at Truman State or who were accepted at Truman State over a particular period of time. And we're looking at the database and we notice that there's a missing banner ID. It goes from like 10,009 to 10,011, and 10,010 is just gone. Would that be something we'd be interested in investigating for purpose of database integrity? Absolutely. And that's something that we actually try to hold on to for a lot of things. Does anybody still have a checkbook? Does anybody write checks anymore? Okay. So what is the purpose of those numbers on the checks? Yeah, to keep track. Okay. And if you write a check, say check number 15, and then you write check number 17, they're going to say, what happened to check number 16? All right. The bank will actually say there's a gap in sequence for you to identify. It says, oh, did it get stolen? Did Dr. Barnes filch my textbook and write a check? It's like, no. That would be way too obvious. My handwriting would give me away because it's god awful. Okay, so I would never steal your checkbook, but yeah, that's a relevant concern, something you want to keep an eye on. All right, so a lot of concepts to go into. Let's go ahead and take everything that we've just talked about and let's compress it down to a single form. So this is going to be the basic UML form that I want you to know for this course, the basic UML presentation. Now, this seems very simple, and it's not meant to be difficult, but there's a lot going on in this diagram. So the very first thing, what did I say my three entities were? Does anybody remember? Resources, events, and agents. You will notice my presentation, resources on the left, events in the middle, agents on the right. And there's a really specific reason why we have those presented in that manner. Events are usually the trigger for agent involvement and for resource usage. So we want events to be in the middle, and then our resources and events are on the other side. Okay. So that's going to be something that we note within that. Now, something to also note here is the delineation of what each of these represent. So the event and AIS class session, we're all here right now in this event right now. What is everybody learning? They're gaining information, okay? You could say grades, okay, but that's not the case, okay? Nobody's trying to get a grade. You're trying to get more knowledgeable so you can go out in the real world and share your expertise of UML diagrams, all right? Who are the agents involved? There's two categories. There's me, the instructor, and then there's the students out there. So we've got these associations that are depicted between those, okay? There's implicit attributes for every single one of these. So we could say, what are the attributes of AIS class session? You could say, what class session is it? We know this is class session number 7, I believe. Yeah, class session number 7, because we've had 6 class sessions, right? What is the topic being covered here? What are the chapters? Okay, what are the assignments listed? This is not in the diagram, but this is implicit to that. You know that there's attributes of the class session, as there are for all of these classes up here. Okay, all these classes listed up here. So we've got the associations, we've got the attributes, we've got the multiplicities. And you may take umbrage with some of these multiplicities, but this is my best interpretation. So AS class session has got to have at least one piece of information. If I have nothing to share with you all, I'm not going to bring you into class and say, how you guys doing? And just nod my head for 50 minutes, okay? I'm not going to do that. I'm not a monster. I'm not a tyrant. I have to share at least one piece of information with you, but often I'm going to share multiple pieces of information with you. So one to many, minimum of one, maximum of many. Information can be shared in one class session, or it can be shared in multiple class sessions. I just talked about primary key, and I also said primary keys we're going to talk about next week as well. That's multiple class sessions. So the multiplicities are fairly intuitive there as well. Now, this is going to be a fairly simple depiction, but I will tell you it doesn't get much more complex than this. All right. This is our base representation. We will add more activities. We will add more associations and more multiplicities. The most difficult part is to actually map the associations as we add more classes. This is the biggest challenge, is that as you add more classes, the associations kind of get out of hand, which is why I try to keep this simple. But at the very basic level, this is all you really need to know. Resources on the left, events in the middle, association on the right. Map all of my classes and all of my classes out, all of my that have to be represented. Then depict the associations and include the multiplicities, and you're done. There is one thing I want to talk about here because it's a little bit nuanced. Okay, it's a little bit nuanced. Remember we talked about conceptual structures? How would a conceptual structure fit within this diagram? Remember, our definition for conceptual structure was this is something, a piece of information that a manager wants more information about. Is there information in this class that I want more information about? Yeah, I give you all assignments, and I want to know how you perform on those assignments. How do I evaluate your performance on an assignment? A grade, okay? So I'm going to have grades that I'm going to assign to you. I've got a grade book. So I could include a grade book as a conceptual structure. So I could say, what would be a connection between the instructor and student? I could actually say there's an association here. I could create a conceptual structure out here. I could say grade book, and this is something the instructor creates and the students receive. All right. Now, I didn't put that in here because, again, I don't want to get too complex. We will look at conceptual structure examples when we get to the process areas. But when you're thinking about conceptual structures, that's how you should think about them, is these are things that don't qualify as resources, events, or agents, but still might fit within our UML structure, our UML framework. The problem is that we try to contain everything within 3 columns, and the conceptual structures say, I'm not going to fit within 3 columns. I'm going to go into my own column over here. And it's really, really annoying and really, really bizarre, which is why I didn't include them in here. All right. Does everybody understand the basic diagram? Now, like I said, this is basically all that you're responsible for. When you do these assignments and homework, when you do these assignments on the or do the questions on the exam, this is the representation that I'm expecting. This type of representation right here. It may be a little bit more complex. It may be more. There may be more classes involved. There may be more more classes involved. Simply because you may have to depict a processing cycle like the revenue process. Unfortunately, I can't tell you it's going to be 4 boxes and 4 boxes alone. Okay, it's not many more than that. It's actually around 8, I think. But you will have to depict that, and that's all there really is to that. That being said, I do want to go into a little bit more depth just to define everything within a true UML structure. So remember, I said that this was the way that UML complexity can operate. So we actually have our activity name up here, okay, our class name up here. And then we also have attributes listed with operations. Now, again, before we get too carried away, you are not going to be responsible for replicating the next few slides. I just want to redefine with how everything fits within the UML diagram. This is what you're responsible for. This is a visual example. Okay, so this is a UML class diagram example that kind of defines all of the different features of information within the UML diagram. So we actually note that customer is going to be an example of a class that we could actually define within the UML diagram. But what is the nature of a customer? Okay, what is the nature of a customer? That would be an example of agent, an agent that we would actually include. Simpler, a sale would be an example of event. The way that this is characterized within traditional UML diagram reporting is that these are stereotypes. These are depictions of how we actually represent those entities and those things in the domain of interest. Now you will notice that you can actually go beyond a little bit of expansion. So agent is pretty much an agent here. Like this is something that would fall in this column right here. So an agent is going to be just pretty straightforward. We have the word event here, but it actually can go beyond that. We can add an adjective saying it's an economic event. So an economic event defines that it's something that's going to be a transaction for monetary value. Or we could define a more implicit event, something that's not going to be something for economic value. We could actually add modifiers to our stereotypes. So the class name actually tells us what the class is going to be. Again, most of our class names will be fairly intuitive. We say the instructor, the students, those are all classes within this particular course. Attributes going to be describe the characteristics of each class. You will notice that in my UML diagram that in the attributes, so they're attributes, so we don't have those present there, but they are still implicitly there. If we were to create a relational database with this information present in there, you would need to actually have the attributes listed so we know what those are. The associations depict the relationship between the class items. Within this UML diagram, it actually specifies what the UML or what the association is. Within our simple UML diagrams, you do not need to pick that. Like you do not need to say students participate in UAS class session. Again, that's an implicit assumption that the reason that they're there is to learn about AIS, but that would be an example of that, okay? So to understand the relationship between the classes. And then primary keys, these are ones you'd identify the records. Obviously, within our UML diagram, those are not going to be present, but they are going to be, they're not going to be listed, but they're still present. So an example of this, the students, what would be the student ID that I would use? That would be the banner ID for the class. That would be the primary key in a database with your information in there, okay? Similarly, if I had the AIS class session, I would say this is AIS class session. I could probably say fall 2025 6, something like that. That would be a primary key to represent this particular AIS class session. The seventh class session in fall of 2025. The good thing about primary keys is they actually allow us to link the tables together. We have the foreign keys that we talked about before. These are actually used to match the tables, which I think is coming up here in a second. Sorry, I don't have a foreign key slide. My apologies. So I want to make sure that we represent the foreign keys. Foreign keys are going to be primary keys of another set that's used to match our tables together. Again, we'll see more explicit examples of that next week. It's just important to know what those are. And then our multiplicities, the really, really confusing part. Again, the multiplicities represent the maximum and minimum of allowed values for an association. So let's interpret this one. Remember, we start with one class and we move to the far multiplicity to interpret this one. So a customer can be involved in 0 sales. So how can you have a customer involved in 0 sales? So possible you could have somebody, sorry, I meant, as I say rhetorically, then somebody was going to be included, but so is that possible you could have a customer that says, I want to do business with your company. And so we give them a customer ID and then we check their credit and their credit is miserable. We say, I'm sorry, we took your information down, we checked your credit, we don't think you'll pay us back. Is that a possibility within an organization? Yeah. So you have a customer that it has 0 transactions. Okay, so that's an example. Many of our customers are going to have multiple transactions. In fact, that for a good business, you hope that most customers come to shop multiple times. It'd be really, really weird if somebody says, okay, I'm going to go to Hy-Vee one time and I can never visit again. Okay, so when I have multiple sales, okay? Sale involves one and only one customer. Again, subject to interpretation, but is that intuitive? Yeah. The interpretation of the multiplicity is very, very important in understanding how we actually represent these associations. Again, that is present within our base UML diagram, something I think is very, very important. What I do think is really, really important to note is even if information does not contain all of the details that are in these slides, make sure you understand these concepts. Make sure you understand the attributes. Make sure you understand the primary key and foreign key concepts, because whether they are present in the UML diagram or not, they will be present within the database that's depicted by the UML diagram. All right. Any questions on that? Any concepts that people do not understand? I think that's fairly intuitive, and it will become a lot more intuitive once we get to some examples that we work through. Okay. There's some other notes here that I'm not going to spend a lot of time on. For the most part, it's not going to get more challenging than what we've got. You can see notes within the UML diagram. Usually it's going to be a dog-eared box that's going to just allow explanations for that. Most of our explanations are going to be verbal as opposed to information that's going to be included in the diagram itself. And then we can actually depict roles in multiple ways. Keep in mind, there can be associations that represent in multiple ways. So you can have more than one association between two classes. I would not worry too much about this particular slide. This is more explanatory as opposed to information that's going to affect what you're going to be preparing in this class. Just to note that if you do encounter an UML diagram with a dog ear or with a multiple association, that is possible. So this is within the realm of possibility, though something that you're probably not going to be replicating on your examples. All right, so that's pretty much it for UML diagrams. Now, again, as you're working through the UML diagrams for your homework and kind of learning these, one thing I would say is come back to this example and use this as your base example. How much so do I do this? I usually, whenever I create a UML diagram, this is my template for how I create them. I actually just copy and paste this image, but then I just eliminate the words that are in here and replace them with whatever words I need. That's how frequently this template will be useful for you. I will tell you right now, you could use this template for your homework and be accurate for the most part. All right. That's just a little bit of a hint for you. You do not have to do this. You don't have to actually create a visual example. You don't have to copy this into Paint and then paint over it. That's kind of what I do. If you want to do this within a tool, you can do this within Visio. You can do this within Excel. If you want to do this by hand, that is fine too. In fact, I recommend that you use at least some examples of writing these by hand because you're going to be doing that on the exam as well. So keep those all in mind. To wrap up, I want to talk a little bit about some rules for decision making, okay? So it's important to note when we talk about decision making are going to lead to business rules, which are going to be very, very pragmatic for businesses to follow. More importantly, we use business rules to actually implement controls of the organization. We've already talked about controls at a very basic level. We're going to be very, very focused on controls given our processes here shortly. So how do we get to those? Well, first of all, we need to understand what are the steps in the decision-making requirements, okay? First is going to be unidentified decisions, all right? So in order to be able to make or understand the decisions, we need to identify what those are. We're going to describe and document those decisions and understand how they impact the business objectives for the process. So documentation, this is the whole thing we've been talking about over the last two chapters. Documenting all these processes and then understanding what is going to be the eventual goal. How do they relate to the process areas that we're having play? Then we need to specify decision requirements in terms of the information and knowledge required to make the decision. Again, this is not implicit in our diagrams, but should be, or not explicit, excuse me, not explicit, but should be presented implicitly. We should be able to understand that with a list of a class, that we should be able to understand what is relevant to that class. We say, here's the student ID, what is going to, or here's the student here, the student as a class, what is going to be the information that's present with attributes, student ID, name, major, whatever the characteristics are of that particular item. Then we're going to decompose and refine the requirements and determining where existing business rules apply and where new business rules need to be developed. These largely go into the associations that we're going to be depicting within our diagrams in order to understand how do these associations get represented from a business perspective. Now, with respect to business rules, we're going to be talking about three general types, all right? The first of these should be pretty straightforward. This is considered to be an obligatory rule. An obligatory rule states what should occur. In every single transaction, this should be the criteria that we follow. So payment should be made in US dollars. If you're a US based company, then you're accepting US dollars and that's it. Now, again, I'm not saying this is something that everybody should follow. This is going to be a case-by-case basis. You can say payments should be made in form of a negotiable currency if you're an international company. If you're a company that wants to accept cryptocurrency, then you can expand this out to say a negotiable currency or a crypto asset. All these are going to be characterized within the term of should. So when we think about obligatory, you're saying this is a business rule that characterized by the term should and actually specifies what the action that should occur within particular transaction area. On the other hand, okay, we've got prohibited. This is saying what should not occur, all right? So no payments are accepted by check. So no matter what the transaction situation is, this company does not accept payment by check. That would be a good example of electronic business so negotiation actually has to take place with an immediate exchange. So electronic transactions must occur. You can't pay a check because that's not an immediate electronic transaction. I guess unless it's an e-check, but I think we're probably talking specifically about a paper check in this particular scenario. In the middle of there, we have the third type of business rule that we can consider. This rule form says what is allowed under certain conditions or what the conditions are. So credit card payments are allowed if the card is American Express. So there's always a caveat to an allowed exception, okay? An allowed exception. This is basically saying this is going to be allowed under a certain circumstance, and we have to specify what that circumstance is. So think about it this way. An allowed rule is basically a prohibited rule, but a prohibited rule that is suspended under given circumstances. So we don't accept credit card payments. However, if you actually pay us an American Express, that's okay, okay? So that's how we can characterize an allowed rule. Now, I know that this is, again, these terms are fairly self-explanatory, but it's important to be able to distinguish the difference between these three particular concepts because these are going to set the stage for how we implement controls within an organization. Last thing I want to talk about, okay, is understanding how we would document this within a decision table. Now, make a note of this. I will not ask you to replicate a decision table either in your homework or on the exam. I think this is the most important aspect of business rules that you need to understand are these three particular items. You should probably be familiar with these right here, but definitely right here. I've asked test questions on this in the past, and you will see homework questions on these. But this is something I do want to characterize. How do we actually represent decision rules within tabular form? And the answer is we need to actually understand what the name of the table is, so the relation that's being represented, what are inputs, what are outputs, and what are the rules that are given. And this is a pretty simple explanation of a rule. So we know what the inputs are. The inputs are going to be the customer and the size of their order. And then once we know the information about the customer, we can provide the context for the decision. So this example here says that if you got a business that's your customer, so it's a business to business transaction, and your customer orders less than or fewer than 10 items. Sorry, I try to always make sure I use fewer instead of less because less is kind of always commonly used. Does anybody else get really, really wound up about grammar issues? That's kind of my pet peeve when people use less instead of fewer and it's incorrect. And I just did it. Okay. I just did it. I said less instead of fewer. So fewer than 10 items. All right. To offer a 10% discount. On the other hand, if a business orders greater than or equal to 10 items, then they get a 15% discount. Individuals, that's only one rule. An individual, so a business to customer transaction, regardless of the size order, is going to be a 5% transaction or 5% discount on the transaction. All right. So these all represent rules, and the rules are distinguished by the characteristics of the transactions. These would be more along the lines of characteristics of allowed rules. I think that's how we would characterize these because none of these actually are saying what should occur. Or I guess what it doesn't say what should occur overall, but what should occur under certain circumstances. So I would characterize these all as allowed rules within our context. And that pretty much does it. Now, again, this is not going to be a standalone chapter. We are going to revisit this again. So if you do the homework and say, thank God I'm done with UML diagrams, unfortunately, we're not quite there yet. But it is a good reference point. It is a good resource. Please make sure you hold on to the notes and the information that we talked about today because it will be important when we start talking about process areas. As we start replicating diagrams, both BPMN and UML diagrams, you'll be able to be responsible for knowing those, how they relate to process areas. All right, homework on Friday. See you all then.